Have you ever considered whether we're truly alone in the universe? On the other hand, accepting there's another component to our existence beyond what we can see. Imagine a scenario where the James Webb Telescope finally reveals that we live inside a black hole. Join us as we delve into this groundbreaking revelation that will make you question everything you thought you knew about the universe. So, what exactly are black holes? They're like something out of a nightmare. Sure, you may have seen them in science fiction movies, but they're far more terrifying in reality. As researchers suggest, black holes in space are immense quantities of matter compressed into a tiny region. Imagine a star several times larger than the Sun, squeezed into a sphere the size of New York City. The gravitational pull is so intense that nothing, not even light, can escape. Scientists have been fascinated by black holes for decades. Since their discovery, researchers have theorized about objects in space so massive and dense that they could trap light. The most famous theories about black holes stem from Einstein's theory of general relativity. Essentially, when a massive star dies, it leaves behind a dense core. If this core's mass is several times that of the Sun, gravity overwhelms everything, leading to the formation of a black hole. Detecting black holes is challenging since they emit no light. However, researchers have developed methods to infer their presence by observing their effects on nearby matter. For instance, if a black hole passes through a cloud of interstellar matter, it pulls that matter toward itself in a process called accretion. Similarly, if a normal star gets too close to a black hole, it can be torn apart, emitting X-rays as it does so. Black holes also significantly impact their surroundings. They can devour nearby stars, produce powerful gravitational effects, and even influence the formation of new stars in some regions while slowing it down in others. But where do black holes come from? Picture stars, once majestic and radiant, meeting their ultimate fate in a spectacular explosion called a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes are born from massive stars that have reached the end of their life cycle in a supernova explosion. Smaller stars, when they die, become neutron stars, extremely dense but not dense enough to trap light. However, if a star is several times the mass of our Sun, it collapses under its own gravity, forming a black hole. As powerful as these collapses are, something strange happens near their surfaces. Time itself begins to behave differently. From the perspective of someone far away, time appears to slow down near the event horizon, the point of no return for anything falling into a black hole. It's as if the star's clock ticks at a different speed compared to ours. Sometimes, when two smaller black holes collide, they merge to form a significantly larger and more powerful black hole. If a black hole interacts with a neutron star, they create an incomprehensible cosmic phenomenon. Scientists have been grappling with the scale of these massive anomalies for a long time. Black holes come in various sizes, from small to supermassive. There's an ominous mystery surrounding them that we still struggle to unravel. Small is relative when it comes to black holes. Stellar black holes, the remnants of giant stars, can be as massive as 10 to 100 times the Sun's mass. There could be millions to billions of them in the Milky Way alone. But there's something even bigger: supermassive black holes. These are millions, if not billions, of times larger than the Sun and are found at the centers of massive galaxies, including our own Milky Way. Renowned physicist Stephen Hawking dedicated his life to studying black holes. His lectures were always thought-provoking, and some of his theories remained unverified due to technological limitations. But hope is on the horizon. A single scientific instrument is making a colossal difference: the James Webb Space Telescope, JWST. This marvel of engineering represents the pinnacle of human ambition. While we've launched other space telescopes before, the JWST is truly extraordinary. Costing a staggering $10 billion, the JWST is the result of a collaboration between NASA, the European Space Agency, and the Canadian Space Agency, along with contributions from over 300 universities. Despite the risks, this ambitious project promises to expand the boundaries of our knowledge. Since its launch, the JWST has achieved numerous milestones. It traveled over 1 million miles to its orbit around the Sun, where it will remain indefinitely. The telescope successfully deployed its massive 5-layer sunshield and primary mirror, both of which had to be folded to fit into the launch vehicle. One of the most captivating moments was when NASA announced that the telescope had captured its first images of starlight. The initial image was of a star named HD 8446, resulting in a mosaic of 18 scattered bright spots. Later, NASA released another image showing the 18 unfocused copies of the star arranged in a deliberate hexagonal pattern. The JWST's cutting-edge technology allows it to study the early stages of the universe after the Big Bang, focusing on the period when the first stars formed. It will also help scientists discover exoplanets and study their atmospheres to determine if they might be habitable. Moreover, the JWST is helping researchers understand how galaxies evolve. By examining the earliest galaxies, scientists hope to better comprehend how the universe has changed over billions of years. Perhaps the most profound questions the JWST seeks to answer are we alone in the universe? And are we living inside a black hole? The telescope has already made remarkable discoveries, including compounds called polycyclic aromatic hydrocarbons, PAHs, near supermassive black holes in 3 active galaxies. These carbon-based molecules, which can act as building blocks of life, were found in regions dominated by intense radiation near these black holes. This raises profound questions. Could everything we know exist because we are inside a black hole? Is it possible that our reality is connected within the event horizon of a black hole, a boundary between the known and the unknown? The James Webb Space Telescope continues its mission to explore the unknown, challenging us to rethink everything we know about existence. As it pushes the limits of our understanding, it may uncover truths about black holes, gravity, and the very nature of reality itself. As the James Webb Space Telescope continues its mission, it will push the limits of our understanding and potentially answer questions we've been asking for centuries. This telescope is more than just a scientific instrument. It's a window into the profound secrets of the universe. Its discoveries could reveal not only the mysteries of black holes and exoplanets, but also help us grasp our place in the cosmos. Will it answer whether we are truly alone in the universe? Will it help us discover other forms of life, possibly hidden in the depths of space or in the atmospheres of distant planets? The JWST's powerful instruments are capable of probing deeper into the universe than any telescope before it, uncovering structures and phenomena that were once invisible to us. This telescope has the potential to change everything we thought we knew about the universe, about gravity, and even about time itself. The more we learn about black holes, the more we may come to realize how interconnected everything in the universe truly is. Perhaps we are all part of a grander cosmic story, one that the JWST is just beginning to unfold. But the answers it uncovers will not come without raising even more questions. The more we understand, the more we may wonder about the true nature of reality. Are we merely passing through a cosmic experiment? Or are we, as we appear, part of a larger plan, one that spans dimensions we cannot yet comprehend? The JWST will be at the forefront of this inquiry, examining the universe in ways that challenge our imagination and understanding. This telescope promises to transform the future of space exploration and the way we think about other worlds, stars, and black holes. As we journey deeper into the unknown, the JWST is poised to open the most remote corners of space, perhaps allowing us to comprehend phenomena like dark energy, the Big Bang, or the true mechanics behind gravity. It's an exciting thought. With the help of this remarkable machine, humanity may finally uncover the answers that have eluded us for centuries. As we wait and watch, one thing is certain. The James Webb Space Telescope represents humanity's unquenchable thirst for knowledge, our relentless curiosity about the universe, and our drive to understand the unexplored world. It's more than just a mission or an instrument. It's a reflection of who we are as a species, reaching out to the stars not just for answers but for understanding. The discoveries the JWST will make are not just about the cosmos. They are about us and how we fit into the grand scheme of existence. As the JWST continues its journey, it will uncover new truths about the universe that may change the course of history. The telescope's revelations will not only broaden our understanding of space but could reshape the very way we view ourselves and our place in the cosmos. And as we begin to ask deeper questions, we will find that the universe is far more mysterious and interconnected than we ever imagined. In the end, the James Webb Space Telescope is not just an instrument. It's a symbol of humanity's quest for knowledge, our desire to understand the mysteries of existence, and our boundless curiosity about what lies beyond the stars. We are on the precipice of a new era in space exploration, one that will change the way we see the universe and our place within it. As we peer further into the vastness of space with the James Webb Space Telescope, we stand at the edge of profound discoveries that may forever change our understanding of existence. Each image, each data point it sends back to Earth, carries with it the potential to rewrite the story of the cosmos and our role within it. The telescope's ability to see deeper into the infrared spectrum allows us to look back billions of years to the very moments after the Big Bang, a time when the universe was still in its infancy. These glimpses into the past are not just scientific achievements. They are windows into the origins of everything we know. With every new observation, the JWST challenges us to rethink what we thought was possible. Its instruments, designed with unmatched precision, are capable of detecting the faintest signals from the farthest reaches of the universe. These signals might tell stories of how galaxies formed, how stars ignited, and how the basic building blocks of life began to assemble in the most unlikely of places. But beyond the scientific, there is something deeply philosophical about what the JWST represents. It reminds us of our place in a universe that is unimaginably vast, a universe where our planet is but a tiny speck in a sea of countless stars and galaxies. It forces us to confront the possibility that we are not alone, that other forms of life, perhaps similar, perhaps vastly different, might exist somewhere out there. One of the telescope's most ambitious goals is to study exoplanets in unprecedented detail. By analyzing the light that filters through their atmospheres, the JWST can determine their composition, temperature, and even the presence of molecules that might hint at life. Imagine the moment we discover a planet with conditions strikingly similar to Earth, orbiting a distant star in the Goldilocks zone, a region where temperatures could allow liquid water to exist. Such a discovery would not only confirm our suspicions that life could exist elsewhere, but it would also raise deeper questions. How common is life in the universe? Is it inevitable wherever conditions are right, or is it a rare accident unique to Earth? And if we do find evidence of life, what might it look like? Could it be simple, microbial life forms or something far more complex and intelligent? The answers to these questions could fundamentally alter our perspective on life, humanity, and the universe itself. They could force us to redefine what it means to be alive, to exist, and to be a part of something so much larger than ourselves. The James Webb Space Telescope, in its quest to unravel the mysteries of the cosmos, is also embarking on a journey into the unknown aspects of physics and astronomy. It may provide clues about the nature of dark matter and dark energy, two of the most perplexing and least understood components of the universe. Together, they make up about 95% of the universe's total mass energy content, yet their properties remain elusive. By studying how galaxies move and interact, the JWST could help us better understand these invisible forces shaping the cosmos. It might even provide the key to